In this question was asked in GATE Computer Science. We are asked to consider the following system of linear equations, and it is given that the second and third column elements are linearly dependent, and we are asked to find out for how many values of A this system of equation has infinitely many solutions. So this was asked in GATE Computer Science, and this is a simple question. We have done a lot of problems like this. For a system of equation to have infinitely many solutions, we must have a rank of A. If we denote it like Ax equal to B, then rank of A should be equal to rank of the augmented matrix and should be less than the number of unknowns for the system of equation to have infinitely many solutions. Here the number of unknowns is 3, so it must be less than 3. This is the condition that must be satisfied for the system of equation to have infinitely many solutions. Now let's form the augmented matrix. To check the rank, we have 2, 1, minus 4, 4, 3, minus 12, 1, 2, minus 8, and we have the matrix A, 5, 7. We have to find its rank. Now for that, to make the calculation easier, I will just now to convert it into row echelon form, we need to do some transformations to make these two elements 0. Now how we can do that? We are going to, so R2 will be R2 minus 2 times R1. This will make 4, 0, and similarly R3 equal to R3 minus half R1. So by using these two transformations, let's see how can we reduce this matrix. We have the first row as it is. We have 0 here. We have 3 minus 2, 1. We have minus 4 here, and we have 5 minus 2a here. Now here we have 0, 3 by 2, minus 6, and here we have 7 minus a by 2. So we have reduced the first two elements to 0. Now we have to make this 3 by 2 to 0 by using some elementary transformation. Which transformation we can use? The transformation we are going to use here is R3 here. R3 equal to R3 minus 3 by 2 R1, so that this element can be made 0. By applying this transformation, the matrix will reduce to, we have the first row 2, 4, minus 4a, the second row 0, 1, minus 4, 5 minus 2a, and the last row we have 0, 0 here, we have 0 here also, that is minus 6 minus 3 into 4 by 2, that will be plus 6, minus 6 plus 6, that will be 0, and here we have 5a minus 1 by 2. Okay. Now for the system of equation to have infinitely many solutions, we have already found out the criteria. We should have rank of A equal to rank of the augmented matrix should be less than the number of unknowns. For that, surely the rank of A here is 2, because this is the matrix A and the rank is the number of non-zero rows in the row echelon form. Here it is 2. So for a system to have at least a solution, the rank of A should be equal to rank of the augmented matrix. That means this element here must be 0. So we have 5A minus 1 by 2 equal to 0. There is 5A minus 1 equal to 0 or A equal to 1 by 5.